So we are studying the first part of mechanics, that is kinematics, which means it is study of motion without studying about force, which is the cause. Now, without studying force, what all things remain? So still we have so many things: position, velocity, acceleration, time, xt, vt, at, vx, ax, av, all these relationships. So those things come under the study of kinematics. And now I say that in kinematics, before studying, we need to understand these terms. Always, wherever you go, whatever thing you want to understand, first you should understand the terms used in that chapter, whether it is physics, chemistry, biology, whatever it is. Because these terms, they may not have same meaning as we have in day-to-day life, right? In day-to-day life, the meanings may be completely different. So you need to understand all these things. Like I will give you some example. Like in day-to-day life, distance and displacement, they are considered to be same, right? But no,
Yes,
in
sir.
physics, we need to distinguish them. Similarly, in day-to-day life, the meaning of work has something else, but in physics, the meaning of work is something else. In your biology, the
Yes,
meaning
sir.
of the body is different. Body means body, body of a person. In physics, a body is thrown from the top of a building. So here, body means some stone or some object, right?
Yes, sir.
Unless we understand the terms, we will get confused. So first, we will understand these terms. Acha. So let's start. So to study motion or to study kinematics, we need to have at least these four things. So these are the requirements. What are the requirements to study motion? At least there has to be an object. Otherwise, to whom you will study? There has to be an object. Second, there has to be an observer. Someone should be there not to study. Otherwise, who will study?
Yes, sir.
So the observer observes the object. Then you must have some coordinate system. Otherwise, how will you measure coordinate of the position of the particle, velocity, acceleration? You need to have some sense of
Yes, sir.
position, coordinate system, right? Coordinate system. And then you need to have clock or a sense of time. Without time, how you can study? There has to be a device for measuring time. There has to be a sense of time. So after having
Yes,
all
sir.
these things only, we can start studying motion. Okay, now coordinate
Yeah.
system. So now basically I am trying to connect various points here. So coordinate system, there are various kinds of coordinate system. Like in chemistry, you come across polar coordinate system, spherical coordinate system when you study the structure of the atom. In mathematics, you might have studied about Cartesian coordinate system. That means x comma y comma z, where a point is specified by x comma y comma z. Do you remember?
Yes, sir.
And in chemistry, do you remember r theta phi? I
No.
have not studied it. Acha. So it's like that. So then there is a polar coordinate system r comma theta. So like that, there are various coordinate systems. Most of the time we will be using Cartesian coordinate system, but slowly we will also learn in some questions when Cartesian coordinate system doesn't give us proper result or it becomes cumbersome to use it, how to use polar coordinate system or spherical coordinate system, that we will see. Okay, anyway, so let's say we have fulfilled all these requirements. Now we want to study motion. So now let's understand the terms. So what is the meaning of rest? What is the meaning of frame of reference? Frame of reference means it is like coordinate system and clock taken together. That is called as frame of reference. Means from which place I
So
am
can you
observing.
repeat? Okay, sir.
Frame of reference means it's a coordinate system plus clock.
Okay,
From
sir.
where the observer is observing. So that is called as frame of reference. Like sometimes, let's say there are two persons traveling in a train, person A and person B, and there is another person standing on ground, person C. Now, person A and B, they are sitting in train, right? So how person A feels about B? So person A feels B is at rest because both of them are traveling in train. Na? Got it?
Yes, sir.
But person C will feel that person B is moving. So now person A feels something else about B. Person C feels something else about B. Now the person B is same, right?
Yes, sir.
So you see from where you are observing, who is observing. Accordingly, the observation will be different. Someone may feel the body to be at rest. Someone may feel the body to be in motion, right? So from where you are observing,
Yes, sir.
that is important. Are you observing from ground? That is called as ground frame of reference. Or are you observing from train? That is called as train frame of reference. Got it?
Yes, sir.
Another example I will give you. Let's say this is a train traveling. You are sitting here, you are playing ball, so you are throwing the ball up, the ball is going up and then it is coming down to your hand and the train is moving, isn't it? So now
Yes,
you are
sir.
throwing the ball, playing the ball, sitting on your seat, and the ball is moving up and down. Okay, now you are observing it. So what do you feel about the motion of the ball? You feel its motion is straight line motion, vertical motion, isn't it? You
Yes,
feel
sir.
that the ball is going up and coming down, ball is going up and coming down, so it is vertical straight line motion. So as observed from train, it is vertical straight line motion, straight line motion. Okay, now let's say there is a person standing on ground. Now how will he feel about the motion of the ball? He feels the motion of ball is not straight line. He feels that the ball is traveling like this, because when you are throwing the ball you are here. When the ball is coming to your hand, you are not here, you have moved here. The train has moved, isn't it?
Yes, sir.
So now the person standing on ground feels you threw the ball here, and when you went here, the ball came to your hand. So the ball has gone like this, and you have gone like this. So he feels this is the path of the ball. So as observed from ground, you feel the motion of the ball is projectile motion. Projectile motion. So you see how motion depends on the observer, how motion depends on the frame of reference. This one is called as frame of reference. So we will see that this is from the frame of reference of train, and this is from frame of reference of ground. Anyway, now we are just studying qualitatively, understanding, okay, such kind of things are there. Later, slowly, we will solve numericals, that from different places, the motion will look different. So from different places, the equation of motion will be different. So from different places, there are different ways of writing equation. But now at least we
Yes,
need to understand that, okay, such things are there. And before writing equations, I need to be careful. My first point should be, I should fix in my mind that I'm observing this motion from which place. Generally students, they don't think about this point, they just start writing equation. Are first specify you are observing from where, and depending on from where you are observing, the equations may be different, the equations may not be same. So if you are just writing one kind of equation from every place, then you will make mistake. So that's called as frame of reference. Is that clear?
yes, sir.
Okay. Now what is rest and what is motion? So rest means, let's say the position of a body does not change with time, then you tell the body is at rest. It's just lying at one place, its coordinate is fixed. At 10:35 morning 6:30, the coordinate was x comma y comma z, 2 comma 3 comma 5. After 2 hours you came, still the coordinate is that much only, 2 comma 3 comma 5. Its coordinate is just not changing with time, then you tell that the body is at rest. Simple. What is the
Yes,
meaning
sir.
of motion? If the position of the body changes with time, its coordinate is changing. It is x1 comma y1 comma z1. After some time it becomes x2 comma y2 comma z2. If its coordinate is changing, then you tell the body is in motion. Okay, now what is 1D motion, 2D motion, and 3D motion? So it's simple. Okay, uh, generally people think like this. तो मैं क्या गलत है वो भी बता देता हूँ. Actually, to understand something, you need to know what is right, what is wrong, and what is sometimes right and sometimes wrong. Right? Then we can tell, okay, I have gained complete understanding. Only knowing what is right is not understanding, because in the exam they will give a question where they will check your misunderstanding. Based on a misunderstanding, they will form a question. And if you know what is right, but if you don't know why something is wrong, then you won't know, you can't solve that question. Got it? So whenever you are studying, let it be any chapter, any subject, you always try to understand what is right, right? What are the wrong concepts, misconceptions which a student can have from this topic, And what are the shortcuts which sometimes work and sometimes don't work? Sometimes, many times, people in the name of shortcuts, they don't remember concepts and they don't remember when the shortcut works and when the shortcut doesn't work. They are more concerned about remembering shortcuts only. And the examiner gives such a question where the shortcut doesn't work, and the person applies that shortcut and comes back, right? So we need to also know where shortcuts work and where they don't work, their limitations, right? So I tell that we need to understand understandings, misunderstandings, and partial understandings. Acha, now some misunderstanding, what people think and what it is not. Sometimes people think 1D motion means, if one coordinate axis is required, then it is 1D motion. 2D motion means if two coordinate axes we are using, then that is 2D motion. And if we are using three coordinate axes, x, y, z axis, then that is 3D motion. So here is a small mistake. What definition I said? Now I said 1D motion means if we are using one coordinate axis to study the motion. 2D motion means if we are using two coordinate axes, x and y, let's say, then that is 2D motion. 3D motion means if we are using one x, y, and z, three coordinate axes, then that is 3D motion. It's not like that. See, every small word can make difference. For example, let's say here is a room. So now we are studying 1D motion, 2D motion, and 3D motion. Let's say here is a room. You are able to imagine the room, and let's say here is
Yes,
a
sir.
diagonal. Here is a diagonal. This is called as body diagonal. This is called as body diagonal. Achha, now a mosquito is flying. Mosquito is flying, let's say, in this direction. So what kind of motion is it? Is it 1D motion or 2D motion or 3D motion? Let's name this as x-axis, this as y-axis, and this as z-axis. Now the mosquito is flying like that. So what kind of motion is that? 1D or 2D or 3D? Guess it.
Sir, 1D.
But I have used three coordinate axes, x and y and z, and you see the x, y, z, all three coordinates of the mosquito are changing with time.
Then 3D.
So no, you were correct. It is 1D motion. So the definition is not that you know how many coordinate axes you have used. The definition is how many minimum number of coordinate axes can be chosen to study it. If you are using more, that's your problem. Got it? Right. So what is 1D motion? 1D motion means you don't require to. With one axis, things can be managed. So 1D motion means the minimum number of coordinate axes required to study the motion is 1. 2D motion means the minimum number of coordinate axes required to study the motion is 2. And 3D motion means the minimum number of coordinate axes required to study this motion is 3. Did you get the definition? So that minimum word was missing, which was creating this confusion. So here you see, I need to just take this as my x-axis. Let's say I take this diagonal as my x-axis. So now I don't need y and z. Right? Now I can tell that the mosquito is only moving along x-axis. Its only x coordinate is changing. Y and z coordinate, they are not changing. And so I can consider this motion as 1D motion. I don't need 2 or 3 axes to study it. Is it clear? Let's continue. So you understood what is 1D motion?
Yes, sir.
So 1D motion ko we can write down the definition as you can write down the definition and give example. 1D motion means you can write down the minimum number of coordinate axis required is 1. The minimum number of coordinate axis required is 1. Or you can tell motion contained in a straight line. It is motion contained in a straight line. Got it?
Yes, sir.
What is 2D motion? So 1D motion means minimum number required is 1. We don't need 2 or 3. If we are taking, that is our problem. Right? But it has to be classified in 1D motion only. So the simplest way is look at it. Is the motion contained in a plane, in a line? Is the motion not going out of the line? Is it within a line? Then it is 1D motion. Okay, 2D motion means you can tell the minimum number of coordinate axis required is 2. The minimum number of coordinate axis required is 2. Okay, or you can tell it is motion contained in a plane. Motion contained in a plane. Got it?
Yes, sir.
Like let's say I throw a ball and the ball goes like this, right? It starts from here at an angle theta and it reaches here, let's say. This is x-axis and this is y-axis. So now to study it, at least I need 2 axes. This is not contained in a line. This doesn't come within a line. This goes out of a line, but always it stays in a plane. So this is a 2D motion. An example is this: a ball thrown on at an angle theta from ground. Acha, what is 3D motion? 3D motion means here if you take one coordinate axis, it's not sufficient. If you take two coordinate axis, still it's not sufficient. You have to take 3 coordinate axis to study it. 2D motion means one coordinate axis is not sufficient. You have to take 2 coordinate axis to study it. What if you take more than 2, 3? That's not required. Right? In 3D motion, 1 is not sufficient, 2 is not sufficient. You have to take 3 coordinate axis, right? So that is 3D motion. So we can write down this as the minimum number of coordinate axis required is 3. Coordinate axis required is 3. Or the motion which is not contained in a line or a plane, but it is contained in a space. Okay, got it? Example: a monkey jumping. Monkey jumping. Is that clear?
Yes, sir.
So after having studied the 3 types of motion, now we will focus on 1D motion and kinematics. So we are studying kinematics only, but in kinematics also we are focusing on 1D motion. And if you have a grip on 1D motion, then you can solve anything. Then you can just extrapolate it. It becomes 2D motion and 3D motion. You just generalize it. It becomes 2D and 3D motion. Clear?
Sir, can you show the jumping of monkey in 3D motion? Like,
Oh, things
I'm a bit
cannot be.
confused.
You just imagine a monkey jumping. This is a room. It goes from here to here, then from here to here, then from here to here, then from here to here, here to here. Got it? Now you see this complete motion.
Yes,
This is not within a line or within a plane. It's just random. So it is
sir.
to study it. We need 3 coordinate axes. One more thing. 3D motion, they cannot be exactly represented in a 2D plane. We are studying in a paper. And paper, we can't represent 3D objects. So whenever we represent, we have to imagine, right? Many things has to be imagined. So diagrams are not exact or accurate. In diagrams also, most of the things we have to imagine. For example, and many times people don't understand things, therefore they get confused. What is this?
Or a circle, closed figure.
Acha, can it be a circle?
Yes, sir.
Can it be a ring?
Yes,
Ring?
sir.
Can it be a disc? Can it
Yes,
be a
sir.
can it be a sphere? Can it be a hollow sphere? Can it be a solid sphere? Now in 2D plane, na, for everything you have to do it like this only. Whether you want to draw a circle or a ring or a sphere or a disc, you have to draw it like this only, right?
Yes, sir.
So by looking at it, you can't tell what it is. You have to study what is written there, what is written in words, the context. Got it?
Yes, sir.
Huh. What is this? What is this?
Sir, an oval.
Ellipse. Oval, ellipse. But this can also be called as a circle. This is a ring, right? Sometimes we want to see rings which are perpendicular to the plane. Then we show it like this. Got it? Now, can you
Yes,
imagine
sir.
this forms a cone? So, what kind of circle it is? It is a circle, isn't it? But this circle is
Yes, sir.
perpendicular to the plane. So, when we are representing it, it looks like oval, isn't it?
Yes, sir.
So, you need to be careful while studying diagrams in physics. So, motion contained in a straight line. You see, that is the name of the first chapter. And then the second chapter comes motion contained in a plane. And then this chapter doesn't come. Because it is understood that as 1D motion is converted into 2D motion, like that the student should be intelligent enough to convert that 1D motion into 3D motion. So this chapter doesn't come, and then it directly go to dynamics part, that is Newton's laws. So you see, we are progressing like this, right? From mechanics, we are progressing like this. In mechanics, first we are studying kinematics, then we are going to dynamics. In kinematics, we are
Yes,
first,
sir.
studying 1D motion, then 2D motion. So that's how the chapters evolve. So if you remember like this, you will never forget. Like students tell, sir, what I have studied in first chapter, now I have forgotten because now I am studying fourth chapter. But actually, you can't forget if you remember the flow. You know that complete physics is this, and out of that, I have reached up to this much. So how you can forget the remaining things? Only when you don't connect the points, don't connect the dots, everything seems to you discrete, and then you forget. So the way to remember is make them connected. Is that clear?
Yes, sir. Yes, sir.
So now let's study motion in 1D motion, or let's call it as motion in a straight line. Motion in straight line, or this can be called as 1D motion. Okay, so we will study the various terminologies used here. So what are the terminologies? First, oh, first position, then displacement, displacement, then distance, then velocity, then speed, then acceleration. So let's understand these terms accurately. In class 9th, you might have come across all these terms. So position means
Yes,
it's
sir.
basically coordinate. For 1D motion, we represent it by x. For 2D motion, we will represent it by x comma y. For 3D motion, we will represent it by x comma y comma z. Is that clear?
Yes,
Achha,
sir.
displacement, we represent it by delta x, or we represent it by xf minus xi. Achha, distance, we represent it by s or delta s, s or delta s. Okay, now uh, what is the difference between displacement and distance? Tell me what you know, you tell me now. Yes.
So distance is the
Hmm.
an object that travels from one position to another.
I'm asking
Like
exactly what is the displacement and what is distance. The difference between them. Achha, are they same or different?
that different.
Can they be same? Sometimes can they be same? Okay, right down. So basically, displacement means displacement means it is shortest shortest distance between initial and final position. Shortest distance between initial and final position. So you find the initial position, you find the final position, join them with a straight line. That's the shortest distance between them. That's called as displacement, right? Displacement does not give us the path traveled by body. You know, for example, let's say the person moved like this. So the person went like this. This is the initial position. This is the final position. If I ask you what is the displacement, then what do you do? You join this first point and last point, and we call this as displacement. This straight line. This is called as displacement. So displacement has nothing to do with whether the body has traveled along that line or not. Got it? It just tells you
Yes.
the relation of the initial point and the final point. Some kind of relation between them. How far is the final point from the initial point? It doesn't tell you the actual path. Is that clear?
Yes, sir.
Whereas distance means it is actual path length traveled by the body. Actual path length traveled by the body. Achha, you see how the body is traveled. So this is distance. If you take a scale, and if you go on measuring, put your scale from here to here, find out how much it is. Okay, 20 centimeter. Then put your scale from here to here. Then put your scale from here to here. Then put your scale
We
from here to here.
can take the help of a thread also.
Yes, you take the thread and align that thread exactly along the path in which the body has traveled, right? And then you measure that. So distance gives you the actual path length. It gives you the actual path length. Got it?
Yes, sir.
It gives you the actual path length. Whereas displacement doesn't give, may give you, may not give you the actual path length. It gives you the shortest distance between initial and final position. It gives you some kind of relationship, between the initial and final positions. Acha, so technically speaking, this is the difference. And then of course there are other differences also. Like in board exams, when such questions come, you have to write in descriptive ways. So there the other measure differences. It is a vector quantity. It is a vector quantity, and this is a scalar quantity. Vector quantity means it has got a magnitude and direction. Scalar quantity means it has got only magnitude and no direction. Achha, for that there is a different chapter only to study about vector and scalar. That also I will tell you later after some time. So
Yes.
to study motion, some of the most important concepts of mathematics required are differentiation, integration, vectors. उतना तो पता होना ही चाहिए. So after telling you, defining all these terms, then I will tell you. Then I will tell you about those mathematical tools. And that we can start later. First, let's understand what is physics, and start the chapter. Got it?
Yes, sir.
So now you tell, can distance and displacement be equal? Can there be a case, a possibility? Acha, what if the body traveled like this?
When the path is straight.
Let's say the body travels like this. The body started from here and ended up here, and the body traveled in a straight line. Acha, now what is the distance? Now what's the distance? Now this is only the distance because this is only the actual path. Now what is the displacement? This only is the displacement because this only is the straight line joining initial and final point. Got it? So can distance and
Yes, sir.
displacement be same? Answer is yes. Under what condition? The condition is when body travels in straight
Straight
line.
line.
So when body travels in a straight line, then distance and displacement will be equal. कुछ समझ में आया? अच्छा,
Yes, sir.
otherwise which one is greater?
Sir, distance
Yeah.
in the other case.
Yeah. So either distance will be greater than displacement or equal to displacement. Distance can never be smaller, है ना? अच्छा, इसमें और थोड़ा मॉडिफाई करते हैं. तो अभी आपने बोला कि डिस्टेंस जो है it is always greater than displacement. Otherwise they are same. और condition क्या बताया? So the condition for them to be equal is that the body must travel in straight line. अच्छा, check it again. Let's say the body travels like this. This is point A, this is point B. So the body traveled from A to B, and then from B it returned to point C. Now tell me, in this case, is displacement and distance, are displacement and distance equal?
No, sir, because again, in
Let's say this
distance,
is
it
30
again
meters.
travels back.
So if I ask you what each, or let's take a coordinate axis. Let's take a coordinate axis to understand it better. Let's say this is x-axis, this is y-axis, this is the origin, this is origin. Let's take point C's coordinate as 30, 0, and let's point B's coordinate as 50, 0. Now if I ask you what is displacement here, what is displacement here? So this is initial point, isn't it?
So
This is
30,
final point. So how much is displacement? You will tell 30.
30.
If I ask you what is the distance here, so the body has traveled first from here to here, that is it has traveled 50. Then it has come back here, that means it has returned by 20. So if I ask you
70.
distance, then it will be 50 plus 20, that is 70, isn't it?
Yes, sir.
So now here you see distance and displacement, they are not equal, but the body is traveling in straight line. So what is the exact condition for distance and displacement to be equal?
So motion in a straight line.
Here also the motion is in straight line only, na? Still they are not different.
Yes, sir. Uh,
So the right exact condition would be the body should be traveling in straight line without changing direction. Here problem came, they became unequal because the body went up to B and then changed direction and returned to C. है ना?
yes, sir.
So if the body changes direction, then even if it is traveling in a straight line, distance and displacement they become unequal, isn't it?
Yes, sir.
So now you write down the relation between distance and displacement. Likho. If the body travels in straight line without changing direction, if the body travels in straight line without changing direction, then distance and displacement will be equal. Then distance and displacement will be equal. isn't it? In all other cases,
Yes.
in all other cases, कौन सा बड़ा होगा? बड़ा कौन सा होगा?
So distance.
Yes, in all other
Distance.
cases, distance will be greater than displacement. समझे?
Yes, sir.
Okay, now you see, actually, if you can tell this much, if you can tell, if the body is traveling without changing direction, then it's sufficient. If the body is traveling without changing direction means, of course it is going in straight line, because uh, if it goes out of straight line, that means it has changed direction. So in that sense, travel in straight line, ये बोलना जरूरत नहीं है, ये redundant हो गया. So if you can tell only this much, then that also is sufficient. What? If the body travels without changing direction, then distance and displacement will be equal. समझे क्या?
Yes, sir.
इतना छोड़ भी सकते हो. Then also the definition remains good. But ठीक है, समझने के लिए लिख दिए, है ना? One more thing to be noted here. So whenever we make comparisons, distance greater than displacement, so one is a vector quantity, one is a scalar quantity. So what exactly we are comparing here? So of course, when we are comparing with the two vector quantities, or we are comparing a vector quantity and a scalar quantity, when we write such statements, here the meaning is we are taking the magnitudes of both and comparing. There is no meaning of comparing directions, Got it?
Yes,
So
sir.
whenever we tell two vectors are like this, one vector and one scalar, in such case they are equal, in that case they are not equal. So there basically we are comparing the magnitudes, of course. So sometimes they write in all other cases, distance will be greater than magnitude of displacement. Or here they write, if the body travels in straight line without changing direction, then distance and magnitude of displacement will be equal. So either you can add that word magnitude of displacement, or without adding also, if you try to remember that meaning, then it's okay. Got it?
Yes, sir.
Okay, so today it's time, so let's stop here.